Okay, Jen's BAC. Okay, so she had 3 glasses of wine, but each had 1.5 standard drinks. So using the formula, we've got 10 times, that'll be 4.5 standard drinks. Take away 7.5 times the number of hours, which is 3, use brackets, divided by 5.5 times her mass, which is 56, again use brackets, and we get 0.073. How long in hours and minutes did it take before her BAC was back to 0? So her BAC was that, and it took 0 point per hour to get. So divide that, we get 4 hours and 52 minutes using our DMS button. What would her BAC be after 3 standard drinks in 3 hours? So using the same calculation, but instead of 4.5, we're going to replace that with 3, and we get 0.024. Okay, so using the table, "64-kilo woman had no alcohol before she went to the party. What was the BAC at the start of the party?" Would obviously be 0. At the end of the first hour, she consumed 2 drinks. So she's 64 kilos, so she's going to be 0.07. BAC at the end of the second hour. So in the second hour, she had another 3 drinks, which is that, but it's a combination, so she's going to be 0.17. If she had no more drinks, how long would it take? If she reduces that per hour, she's going to take 9 hours and 27 minutes. Why is a heavier person less affected? Okay, they got more blood and therefore more water, so it's diluted. Why are females more affected? They're usually lighter. Okay, so using the table, how many drivers were killed between 2007 and 2011? So drives, all of those, add them up, and we get 3,378. How many passengers were killed between that? Add them up. Passengers, 1529. Now, over the page, it says for C, what is the mean number of male drivers killed per year? So the male drivers, there is 2,535 of those, and there's 5 years, so it's 507 per year. D states what is the range of female passengers killed over the 5 years. So the range highest, so the female passengers, the highest is 158 and the lowest is 127. We get 31. E, what is the median number of female drivers killed? So the median is the middle. So when we rank these, okay, there's 5 scores, so the lowest is that, then that one, and then we have 169. And F, the IQR of male passengers. So the male passengers, so the median is 173. So the upper quartile is between 178 and 179, so that is 178.5. Take away the lower quarter is between 154 and 156, which is 155. So we get 23.5. Obviously you could rank them in order. So 154, 156, 173, 178 and 179. You can see that's the middle, there's the lower and there's the upper. Okay, for 5, what's the total number of drivers and passengers over 4 years? So we've got 2,581 and 1,205. So the total, add those together, gets 3,378. What is the mean of the male drivers? So it's going to be 2,581, or average, over 4, which gets us 65.25. The interquartile range, the number of females over the 4 years. So we've got 274 as the lowest, 259, 303, and then 333. So that is the mean. That is, sorry, the median. That is the lower quarter, and that is the upper quarter. Now, so to get the lower quarter, add those two and divide by 2. So you get 284.5. Add those two, divide by 2, and you get 318. So 318 upper minus 284.5 lower gets you 33.5. We're in a sense suggesting why there are significantly less females killed. On average, they're more sensible drivers. Okay, draw a sector graph. We're not going to do that, but let's just say the numbers killed in 2010. So if you're looking at males, there is 623. If we add up both of those, we get 918. What fraction of 360 degrees? And we get approximately 244 degrees for the male, and 116 is left over for the female. Okay, question 6. Scott took 3¼ hours to drive 210 k's. So speed is distance over time. Now we'll leave it as that, and we get approximately 65 kilometers per hour. How long in hours and minutes would it take him? Okay, so time is distance divided by speed. So we're talking about 350 divided by 65, and we get 5 hours and 23 minutes using our DMS button. How far? So distance is speed times time, so it's going to be 65 times 4 DMS 20 DMS, and we get 282 kilometers. Alright, truck driver, 150 k's. He brakes 3 seconds after he saw a sign on the truck stop. He travelled 810 under brakes before coming to a stop. So we need to work out what was his reaction distance. So we've got 150 kilometers an hour. We need to times by 1,000 to get into meters, and divide by 3,600 to get into seconds. Times it by 3 seconds, because that's our reaction time. So speed times time, which gets us 125 meters, plus the 810 will get us 935 meters. Now George is travelling at 65 k's, so 65, we're going to divide by 3.6, which is the same as times by 1,000 divided by 3,600 to get into meters per second. His reaction time was 1.2, which gets us 21.7. We are going to add the 24 meters under brakes, which gets us 45.7 metres. Did he hit the cow? No, he didn't, because the cow was 70 metres ahead. Okay, with 9, what do you notice about braking distances? They're all the same. What do you notice about the reaction time? As you increase your reaction distance, as you increase your reaction distance, you increase your reaction time. And actually, as you double the reaction time, you double the reaction distance. Okay, now part C over the page. Find the values are A, B and C. So A is obviously just plus in the reaction distance and then braking distance. So we get 23.7 metres. B 34.8 metres and C 57 metres. Now D, an 85-year-old driver has a reaction time of 4 seconds. Would he stop in time if he sees a child 50 metres ahead? Alright, so on a wet road, 4 seconds, we have a reaction distance and a braking distance of 57 metres. So therefore, 50 metres is where the child is. He will not stop in time. E suggests 2 strategies for this driver. Well, the obvious strategy is shouldn't drive. 4 seconds is a ridiculous time. But obviously he could also drive slower than the speed limit. Alright, 10, we've got dry versus wet. Okay, difference between 50 and 100 in a dry road. So there's 100, there's 50, you're looking at 50 metres, take away 12, which gets us 38 metres difference. How much farther will the car travel under brakes on a wet road at 60 compared to that of a dry road? So the difference there, we've got 10 metres. If a car travels 50 metres under brakes on a dry road, so we can clearly see they're travelling at 100 kilometres an hour. Approximate speed of a car on a dry road, that travels 12 metres. So there's 12, we're looking at 50. Write a sentence noting the similarities or differences between braking distances on wet and dry roads. Alright, probably the obvious thing at low speeds, the difference between the two is minimal, but as we increase, it increases dramatically, especially at 100 k's. Actually more than doubles. Well, I actually think it's probably even 4 times as much.